Hi, welcome to another episode of Science Made Simple. I'm Dr. Ryan, and I'm a science specialist here at the Pique Lab. In this video, I'll be analyzing a past year examination question on the topic of electrochemistry. I have also prepared this question for you to download for free by clicking a link in the description box below. So, let's get started. In setup X, P and Q are two different metals. The phrase, two different metals, suggests that X is an electrochemical cell. On the other hand, in setup Y, R and S are carbon electrodes. These suggest that Y is an electrolytic cell. Can you remember what are the differences between an electrochemical cell and an electrolytic cell? Well, the main difference between these two is in terms of energy conversion. For electrochemical cell, chemical potential energy is being converted to electrical energy, while for electrolytic cell, it is the reverse, where electrical energy is converted to chemical potential energy, where it usually drives a reaction. Let us analyze setup Y, which is the electrolytic cell first. For setup Y, we are using aqueous silver nitrate as the electrolyte. I'm sure that some of you are starting to work out the products at the cathode and anode. So, let us do that. Silver nitrate consists of Ag plus cation, which will migrate to the cathode, and NO3 minus anion, which migrates to the anode. Besides this, what our teachers in school have shared is that for aqueous silver nitrate, and in fact all aqueous salts, water is also present. Since water is present, it can undergo self-ionization to produce H plus ions and OH minus ions. This means that on top of Ag plus and NO3 minus, H plus will also migrate to the cathode and OH minus will also migrate to the anode. Since we have two cations at the cathode and two anions at the anode, the next question that we should be asking ourselves is, which of these cation and anion will be selectively reduced and oxidized? You may pause the video and think about this question for a moment. For the cathode, we should be looking at the species which is less reactive. So if you recall the reactivity series, you will notice that silver is below hydrogen. Therefore, between these two species, Ag plus will be the one that will be selectively reduced. Are you able to write the half equation for the reaction happening at the cathode? At the cathode, Ag plus accepts an electron, itself is reduced, and you will notice the formation of silver metal. What about the anode? You should have learned that for aqueous dilute solutions, OH minus is always the one that is preferentially oxidized. This means that OH minus will undergo oxidation where it loses electrons to form oxygen gas. Besides this, if you focus on OH minus, you should be able to observe that its concentration will be decreasing in setup Y. And if the amount of OH minus decreases, we expect the solution to be less alkaline. So what does this imply about the pH of solution Y? This implies that the pH of solution Y will decrease after some time. So this means that statement 1, which says that the pH of the electrolyte in setup Y decreases after some time, is correct. Going back to the table that we have drawn earlier, we can see that at the cathode, silver is formed. If you look at the text above, you can see that the question says that silver is formed on the carbon electrode S. Therefore, we can infer that S must be the cathode. Conversely, R must be the anode. And if you look at the cathode half equation, you can see that Ag plus is accepting an electron. This suggests that electrons must be flowing into the cathode S. Conversely, electrons will be flowing out of the anode. Can you take a few seconds to draw the electron movement along the wire? If you have done so, you will see that statement 2, which says that electrons flow in a clockwise direction in the circuit, describes the electron movement correctly. Now, let us focus on setup X. What you need to think of next is, given the electron flow in this direction, which of these metal is the more reactive metal? Will it be P or Q? In order to approach this, you need to recall the key concept that you have learned for electrochemical cell, which is electrons always flow from the more reactive to the less reactive metal. In setup X, we can see clearly that the electron is flowing from P to Q. Therefore, we know that P must be more reactive than Q. This implies that statement 3 is incorrect. Besides this, another important concept tested here is that the more reactive metal prefers to be oxidized, hence it will become the anode, and vice versa. As such, P is the anode and Q is the cathode. Finally, let us try to figure out the products at P and Q. Do know that for X, we have dilute nitric acid as the electrolyte. Using the same method as we did for Y, you should know that H plus migrates to the cathode and O3 minus migrates to the anode. Similarly, do not forget the existence of water, which you can infer from the word dilute. So besides H plus, OH minus is also present. At the cathode, you only have H plus. So the only possible reaction is the reduction of H plus to form hydrogen gas. The next step will be to think about a possible observation at electrode Q. I believe you know that hydrogen is a colorless and odorless gas, and you will observe effervescence at Q. This means that statement 4 is correct. Therefore, answer is option 4. Before we end off, let me ask you an additional question. What do you think are the possible observations at anode P? Now, the most important thing then to tell yourself is that P is a reactive electrode. Unlike inert electrodes, reactive electrodes take part in electrochemical reactions. So what will happen is that P will be oxidized and form ions of charges +1 or +2, depending on what P actually is. After some time, you will notice that anode P decreases in both size and mass because it has been reacted away. Thank you for watching, and I hope you have enjoyed this video. If you found this video useful, do give us a thumbs up. If you'd like to check out more videos by us, do click on the links on the right hand side. Last but not least, don't forget to subscribe to our channel for more interesting videos. Thank you, and I'll see you next time. Bye!